Okay, Chapter 8. This video goes over, it's an overview video. It goes over what a confidence interval is. We need to introduce a new probability distribution that's a lot like the standard normal, but it works better when you have small sample sizes. It's called the t-distribution. We use it a lot as we move forward. And also, I want to give you a formula for determining how much data to collect. Before you ever start, you've got to collect data. There's a formula that will do that. So let's go through it. Really want to focus on, you can see what I've got grayed out. We're not going to use the standard normal confidence interval formula. We're going to jump to the t-distribution based confidence interval. And the reason for this is because we never, ever know what the population standard deviation is. We don't know what sigma is. It's always uncertain. So we want to use this when we don't know what the population standard deviation is. Secondly, is that when you have a small sample sizes, let's say you have a sample size of 4 or 5 or 6 or something that's small. In that case, you don't want to use the standard normal. You need to use a distribution that takes into account less data, and that's the t-distribution. After we do that, we'll talk about how to a formula for sample size. After this video, I'll do another video where I work through some Excel-based formula. So here is the t-distribution. You use it when you don't know the standard deviation. It looks, the t-distribution you plot it is based on this formula. It looks like this, and guess what? It looks normal. It's specifically, it looks standard normal. It's centered at 0, and what we have when we generate a confidence interval is in the middle is our confidence. So my confidence is 1 minus alpha. So typically you have a confidence of like 95%. So if your confidence is 95%, that means alpha would be 5%. And then alpha over 2 would be 2.5%, 2.5%. And so to generate a confidence interval on the population mean, this is the formula. It's your sample average plus t, this t value, and I'll show you how to do this in another video, multiplied by the standard deviation divided by the square root of the sample size. And then the lower end of the confidence interval would be the x bar, the sample average, minus t, so it would be this one, which is the same number as this one, just the minus, multiplied by the standard deviation divided by the square root of n. So let me show you what the t-distribution looks like. So the orange is the standard normal, and you can see it's 0, and if you go out plus or minus 3 standard deviations, there's plus 3, minus 3. The area between that is a 99.73%, and between plus or minus 2 standard deviations is 95%, 95.45%, plus or minus 1 is 68%. But look at the t-distribution, what it looks like. When the sample size is small, you can see it's flatter. It has more area under the tails. So if you wanted to generate a 95% confidence interval on the t-distribution, it would have to be further out here. You would have to have a t that would be closer to plus or minus 4. Now look what happens though if you got a larger sample size. So I'm going to increase the sample size by 1. Let's say you have a sample of size 3. See what happens to the t-distribution? It starts looking more and more normal. And as your data gets bigger, you wind up having a normal distribution. If I go out to 10, it's almost identical. If I go out 30, it's practically the same thing. And if this was really, really big, just stupid big, then the t-distribution and the standard normal are identical. So you really never, ever need the standard normal. You can always use the t-distribution, and when you have a large sample size, you know that it's going to look normal, but when you have a small sample size, You don't want to use the standard normal, you want to use the t-distribution. It will be more reflective, more accurate than using the standard normal when you have small data. So this is the confidence interval formula we're going to use. I've got a spreadsheet out there that we'll work our way through, and I'll work through. This is a calculator that you can use exactly like this to do it. I want to give you a sample size formula. Now, keep in mind, the sample size is before you start your research, how much data do you need? So you haven't done anything, you've got something you want to study, and you're trying to determine how much data to collect. The formula then is based on what your z-value is, which is based on your confidence. It's based on some estimate of your standard deviation, and then this thing called the precision, and S right here is sigma. That right there should be sigma. It needs to be a Greek letter. We can fix that quick enough. So to use this, we'll go through an example in Excel, but most of the times we don't know what the standard deviation is. So we can ballpark this by doing a thought experiment and estimating sigma by taking the biggest possible value minus the smallest possible value, divide by 4 to ballpark what sigma would be. Okay, that's the formula. Again, I'll have another video that goes over how to do this in Excel. Thanks.